In the spring of 2026, public high school students sat for more than 4.8 million advanced placement exams, and now those score distributions are public. This visual matrix outlines the scoring standard. Exams are graded on a scale of 1 to 5. A 3 is generally considered passing. Macro data, you immediately see massive disparities. At the very top, AP Research holds a 90% pass rate. At the bottom, AP Music Theory trails with only 59% of students scoring a 3 or higher. The instinct is to look at this spread and assume a low pass rate means an exam is simply harder. The data tells a different story. Pass rates are actually driven by cohort selection bias, prior student knowledge, and highly specific pedagogical bottlenecks. By treating the 2026 results as a diagnostic map, we can pinpoint exactly what separates baseline competency from total mastery across every academic discipline. The Math and Computer Science cluster features some of the most extreme score variations in the entire dataset. This side-by-side chart compares Calculus AB with Calculus BC. AB has a 65% pass rate, BC has an 82% pass rate, and nearly half of those students earned a perfect 5. The reason for this gap is selection bias. Students taking BC are mathematically accelerated and heavily filtered by their schools. For the broader cohort taking Calculus AB, a specific conceptual hurdle dictated the scores. Unit 6, Integration and Accumulation of Change. This unit functioned as the ultimate filter. Students who scored 1s and 2s failed these questions completely, while those earning 5s mastered them. In the tech disciplines, Computer Science Principles has a 63% pass rate, and Computer Science A sits at 66%. This line graph shows student accuracy rates, with a steep drop at code analysis. In CSP, this was the primary gatekeeper. Students earning 3s averaged 70% accuracy here, while 5s answered 100% correctly. Meanwhile, AP Pre-Calculus debuted with a massive 82% pass rate, driven by extremely high student proficiency in exponential and logarithmic functions. In quantitative disciplines, administrative prerequisites dictate the overall pass rate, but mastering one highly abstract unit dictates who earns a 5. Moving to the sciences, we see a solid baseline of performance: biology at 71%, chemistry at 75%, and environmental science at 69%. This graphic shows overlapping bell curves for algebra-based Physics 1 and calculus-based Physics C, electricity and magnetism. Notice the thick concentration of 1s in Physics 1 versus the heavy cluster of 5s in E&M. Again, the Physics C data is a symptom of intense mathematical selection bias. E&M requires advanced calculus, meaning the cohort is heavily pre-screened. It does not mean E&M is an easier exam than introductory mechanics. Within these courses, highly specific friction points emerge. In AP Chemistry, the defining hurdle was Unit 7, Equilibrium. Equilibrium requires complex calculations and demanding conceptual shifts regarding Le Chatelier's principle. The material is difficult enough that only 34% of students answered most of these questions correctly. Compare that to AP Biology. This chart highlights how easily students dominated factual recall questions on ecology. But look at the stark contrast on mathematically driven free response questions. Lower scoring students failed to earn points here, even after demonstrating mastery of ecology. True science mastery relies on surviving the bottleneck of strict mathematical application in high-pressure scenarios, rather than simply memorizing natural laws. The humanities represent the highest volume exams in the AP ecosystem. In 2026, over 631,000 students took English language, and roughly 554,000 sat for U.S. history. This massive sample size forces the score distributions into a highly normalized shape. As you can see, the curve swells heavily in the center, leaving very thin tails at the extremes. Even with a 74% pass rate in U.S. history, distinct patterns emerge. More than a quarter of all students achieved perfect marks on multiple choice questions covering periods 1, 2, and 7. This timeline reveals the cohort's blind spots. Performance plummeted in period 4, from 1754 to 1800, and period 9, the modern era. Only 5% of students achieved perfect marks on those specific questions. Similar stable, high-volume performance appears in U.S. government, with a 76% pass rate, and comparative government at 70%. By contrast, human geography sits at a notably lower 66% pass rate, despite students demonstrating excellent data analysis skills on the exam. This discrepancy is caused by the underclassmen effect. Human geography is typically taken by high school freshmen. Age and general test-taking experience drag the curve down rather than the complexity of the geographic content. In high-volume humanities, raw intelligence is normalized by the crowd. Top scores go only to those who master academic writing conventions. The most extreme statistical outliers in the 2026 data are found in AP Chinese and AP Japanese. This skewed bar for AP Chinese shows an 85% pass rate. Nearly half the cohort scored a 5. Why? 70% of test takers are heritage speakers, bringing years of linguistic exposure into the room. AP Latin presents a totally different profile. With a 73% pass rate and 20% earning 5s, it stands out among the language exams because it lacks a modern heritage speaker base. Instead, Latin relies on intense selection bias. The average SAT score of a student earning a 5 in AP Latin is an elite 1500. The AP Capstone program offers another statistical anomaly, boasting exceptionally high pass rates. Research sits at 90% and seminar at 88%. Capstone relies on a portfolio-based evaluation rather than timed multiple-choice questions. Removing that specific standardized testing friction inherently raises the baseline for student performance. The final filter for those seeking a 5 in Capstone is the end-of-course argument analysis. Readers require complex contextualization of sources, punishing students who settle for mere summary. When traditional testing friction is removed, whether by lifelong language exposure or long-term portfolio projects, the standard bell curve breaks entirely. Looking at the macro performance of the 2026 public high school cohort, we can see the broader trends of the entire AP program. In 2025, 24.8. Yet even as the program scales, true mastery remains locked behind distinct cognitive checkpoints. Low pass rates in subjects like human geography indicate younger, less experienced test takers, not material that is inherently impossible to learn. This split screen highlights the contrast. Exceptionally high pass rates, like the SKIO in Calculus BC or AP Chinese, reflect heavily filtered or advantaged cohorts, not exams that are somehow easier. For educators and competitive students, the takeaway is clear. Executing a broad content review is insufficient for securing a 5. Moving from a 3 to a 5 requires hunting down and drilling the specific pedagogical bottlenecks, like code analysis in computer science principles or equilibrium calculations in chemistry. The AP score distribution provides a legible map of academic friction. Students and educators who follow that map to these specific bottlenecks are the ones who conquer the curve.